Hi everyone. Hopefully you all enjoyed our labs this week. We were collecting this population growth data for these blepharisma populations grown under different kind of nutrient treatments and then also for different amounts of time as well. So these populations are of different ages, right? Like I mentioned in class, this video is basically going to go over how we go about, first of all, calculating some of these summary statistics super quickly in Excel. And then also how we're going to be generating that plot that we're submitting as part of our homework for this lab. So this should be the layout of the spreadsheet that you guys were sent by me after class through Canvas, right? We have all of our class data kind of available for us to work with, and then this is what we're going to be calculating our summary statistics from, and then also what we're going to be plotting as well. We should have this kind of layout where we have our four age, day slash day treatments, right? And then for each of those age treatments, we also have three corresponding nutrient level treatments as well. So again, this is 12 treatments total, four age categories and three nutrient level categories, right? These nutrient level categories are going to serve as kind of different series on this plot that we end up making, and then these age treatments are going to serve as our x-axis. So, to get started, let's go ahead and work through how to do these different summary statistics, right? There's five different things that we're going to be calculating today. The first of these is going to be our maximum population size. We're then also going to do our minimum population size, our mean population size, our median population size, and our standard deviation of the population size for each of these 12 different treatments. So the way that we do this is fairly simple. All of these different summary statistics have corresponding kind of functions that we can use in Excel to calculate them really, really easily. So as with all Excel functions, we're going to start off with our equal symbol, right? Equal symbol, right? You can see I have kind of selected this kind of 7-day low nutrient treatment. So that's what we're going to be calculating first, right? So start with our equal symbol. And then for our maximum population size, the function for getting the maximum of a series of numbers in Excel is just simply max. And you can see that comes up as we would expect it to. We can tab, and then now that's going to let us select our data, right? So we can go over to our raw data above and then select the data which we are trying to get the maximum of, right? So the current data series is obviously our low nutrient level 7-day population. So there's 20 different data points. We select those 20 different data points and then we close out those kind of parentheses and we press enter. And that is our maximum population size that we kind of record across those 20 different data points or 20 different replicates, basically, right? So fairly straightforward. We're then going to do the same thing for all the 11 other populations, right? For 12 total populations. So again, you're just using that max function and then you're selecting each row that's corresponding with whatever data series you're trying to calculate. So for example, for the 14-day low, you would select 14-day low population. So this row right here. Your 21-day low would be this row right here. Your 28-day low would be this row right here, and then so on and so forth. Fairly straightforward, just iterating across those different combinations of age treatments and nutrient treatments. Once we finish that, we can then go on to calculating our minimum population size. So again, this is a built-in function that Excel already comes with that we can kind of use um, to get this minimum of each of these different data series that we're looking at, right? So that function being min, and so we start off again with that equal symbol, right? And then just type in min. You can see that the min function comes up as we would expect. We tab. And then once again, we're just going to select the row which has the current data series we're trying to get the minimum value out of, right? That being the 7-day low nutrient population again. We can press enter. We don't have to close out those parentheses. Just press enter, and that is now populated the cell with the minimum value for that data series. So we can keep doing this. Um, Moving on to our mean or our average, right? If you remember from the first lab where we went over some of those basic Excel functions, this is just the average function in Excel, right? Again, we're going to calculate that for the data series. I'm going to close out those parentheses, or that's not really necessary. Once you've selected the data, you can really just press enter and that should populate. There you go. Same thing for our median, start off with the equals, and then this time that function is the median function, right? Pretty straightforward. Highlighting our data again, pressing enter. And then for the standard deviation, that function is STDEV, shorthand for standard deviation, right? So we're going to open up those parentheses. We're going to select our data, and then we're going to press enter. And there we go. We have our standard deviation, our median, our mean, our minimum population size, and our maximum population size for the low nutrient level 7-day-old population, right? We're then going to repeat this across, again, all of these other different treatments that we have, right? So once we've done that, what we should end up with is something that looks a little bit like this, where we have this complete kind of table filled out, right? It's got each of these 5 different statistics for each of the 12 different treatments, basically. Once we have this, we are ready to move on to the plotting stage. And so our plotting for this is strictly going to deal with the mean population size and then the standard deviation of population size. So to get started doing this, it's fairly straightforward. We're going to select, um, one second. Yeah, there we go. So we're going to select the data that we wish to plot, right? That being our mean population size data. We're going to select all 12 treatments, and then we're also going to include in there our low, medium, and high, those nutrient treatments as well, right? So that's going to let us know that each of these is corresponding to a different series, basically, and that's going to communicate that to Excel. For our plot, we're going to go to the Insert tab up top. And then to this portion here, which comes with all these different available plot types, we're then going to select the type of plot that we're looking for, that being like a really basic like line chart, right? This first option in the 2D line portion is what we're looking for. So we can select that. And that kind of spits out this really basic line chart. You can see all the data is already plotted and formatted in the right way. All we really have to do is play around with the formatting a little bit to make this plot a little bit more informative. So that includes like messing around with the chart title. We're going to add some informative axes labels and also axes titles as well. And then one last thing we're going to do is we're going to add error bars that will let us display that standard deviation and incorporate it as part of this figure. Okay, what we can start off by doing is modifying our chart title since that's already present on the plot, and all we need to do is give it something that's more, change it to something, I mean, that's more informative and tells us about what's being plotted, right? And so in this case, what we're looking at is, and what we're displaying is population growth um, for blepharisma across four across nutrient treatments, right? So that is like a perfectly fine title that we could use for something like this. If we want to be a little bit more nitpicky, we could like italicize blepharisma since that is like a genus name, right? And so now we've come up with like a much better chart overall title for this. Next thing we can do is obviously these x-axis labels like the 1, 2, 3, and 4 are not reflective of like the age that these different time points were taken at. So that's something that we can modify also relatively easily as well. So how we're going to do that is in our chart design portion, you will our chart design tab, you'll see this option to select data. If we selected data, you'll also see this option to kind of select our horizontal or category axis labels. So what we can do is we can use this option to select cells that correspond with our horizontal category axis labels. And then we can select 7, 14, 21, and 28 as what we want those axes labels to be, basically, right? So once we've done that, we can press enter. and okay, and that's going to modify it and update this plot for us. So this is much better. These are now accurate to these age treatments that correspond to the populations, right? Other things we would want to do is add our primary horizontal and our primary vertical axes titles as well. So if that's added, we can give these kind of informative um, titles. So for our horizontal axis, probably going to give this something like age in days. And then for our vertical axis, we can call this population or number of individuals, perhaps. Okay, so that's our primary horizontal and our primary vertical axes taken care of. The last thing we really need to do is mess around a little bit with those standard deviations. So adding these to the plot is fairly straightforward. We're going to go back to this chart design portion, add chart element, and you can see that there's options to add an error bar. We're going to select this standard error. Which one of these we actually select doesn't really matter all that much since we're going to end up customizing those values that are actually incorporated into those error bars. But we can start off by selecting the standard error. Once you selected a standard error, you can see that it's come up with these different standard errors that Excel uses some kind of formula to calculate, but that's not what we want the final version of this to be. What we want to include is the kind of treatment specific standard deviation that we calculated individually for each treatment beforehand, right? So how we can modify that is by first selecting our error bars, right-clicking on the error bars, and there that should pop up an option to format the error bars. Once we see this kind of window on the right-hand side pop up that lets us format the error bars, we're going to select custom here for the error amount. Then we're going to specify our values. Once we specified our values, we can select cells within our table here, which correspond with those appropriate standard deviations, right? So again, this is our high populations that we're looking at, and so we can select our high nutrient populations for 7 through 28 days, and that should give us the appropriate standard deviation bars, right? So that'll be our positive error value, and our negative error value should be the same, right? So we can select our data. Again, it's just going to be age treatment 7 through 28 for the high nutrient treatment. So again, press enter. We can click OK, and then that should modify these error bars to now be accurate to each specific treatment, right? You can see now that if we look across these age treatments, um, those error bars are no longer the same across each of these age treatments, right? Which is what we would expect. We can then do the same thing for our medium nutrient treatment, right? We can start off by adding our standard error bars. Same thing as before. I might need to zoom in a little bit so that we can select the error bars appropriately. We want to format those error bars. Select custom specifier values, right? And then for our positive error value, that's going to be the medium. For our negative error value, it's just going to be the same. So that should be done, and you can see that that has now modified the error bar slightly. For our last population, it would be the same exact thing, right? We're adding our standard error bars first of all, but then we are modifying those so that we are able to specify the custom values that we calculated. So our positive error values would be for our low population, right? Our negative error values, those same values as the positive error values. So that's done. We can click OK, and this is basically our finished plot that we're going to be taking a screenshot of and then submitting to Gradescope. One thing you guys might notice is that the error bars across each of these different lines, each of these different treatments overlap quite significantly. And that's not something to be concerned about. The nature of how we're collecting this data means that there's going to be a lot of variation across our different groups and across our different samples in terms of how many individuals we count in each sample. So it's perfectly fine to end up with something like this where you see tons and tons of overlap between the error bars for the three different nutrient treatments. This is exactly kind of similar to what you're going to be submitting to Gradescope. Okay, that should kind of cover this process of making these figures and calculating those summary statistics for this lab. Let me know if you have any questions, and I'd be more than happy to help out.